Hello and welcome to another lesson. This lesson is going to be on using a graphing calculator. We have a problem here from WebWork that asks for a couple of items. First of all, this is the function that we're going to be looking at, and it's asking for a couple of things: the local maximum, local minimum, and the roots. First thing I want to do is look at Desmos to show you what those are. This is our function, 2x to the third minus x squared minus 4 to 3x plus 9. And this is what the graph looks like, kind of from a standard view, so to speak. It looks just like a bunch of lines going up and down. From our study of polynomials, we can, have a reasonable idea of how many curves it has and how many times it crosses the x-axis and things of that nature. This particular graph is going to cross the x-axis 3 times, and we can tell because it's a third-degree polynomial. And this is the x-axis right here. So we can see here, that's one of the roots. That's another root. And this is the third root over here. They are crossing at irrational points. So the roots are where the graph crosses the x-axis. We're looking for a local maximum, and if we see the way the curve behaves, if it crosses the x-axis 3 times, that means it has to move up and down. It has to move up and then down somehow. And we see it right here. We see here as we look at it, or maybe take our finger over it from left to right, we see this thing traveling up and down, and it's going to reach a top point somewhere, and that is what the local maximum is, right? This point right there. That's called a local maximum. The reason why it's not called a regular maximum is because technically this graph from here is going to go up and up and up forever. So the actual absolute maximum is equal to infinity. This is a local maximum, which means it is the top of a hill, so to speak. And if since we have a local maximum, we can look to find a local minimum as well. And that's going to be all the way down here. Again, this is how we study the behavior of polynomials. We see a local minimum at this point right here, kind of, again, if we read it from left to right, following this cursor along, we see it, the y values go down and down and down, and then start to go up and up and up, right? So somewhere between there, we're seeing this graph turn around. And again, from here, this graph is traveling down to negative infinity. So the absolute minimum is negative infinity, but this is a local minimum point. Since you won't have Desmos, we are going to look at the local maximum, local minimum, and the roots on our TI-84 clone right here called Calculate 84. A TI-83 works the same as separate graphing calculator, Casio, HP, Sharp, Katiga. Those are going to work differently. So if you have one of those calculators, you might have to look up some instructions or read the manual or get some help from somebody or something. So let's take a look at how to graph on a TI, Texas Instruments calculator. First thing we want to do is hit the Y equals button. And here's where we're going to type in our function, 2. Let's say the X button is over here where it says X, T, theta, that kind of thing. That's the X button. So 2x to the third, hit the caret and the 3. Remember to press the right arrow to get back to the base level, minus x. And this, these calculators have a squared button right there. So that's good. You don't have, it's already stays on the base level, minus 43x plus 9. So this is our function. So once you have done this, hit the graph button. And what this graph shows you is the standard -10 to +10 window, right? That is x values of -10 over to +10 and y values of the same nature, right? Let's see, maybe, okay. So this looks a little rectangular. Yours on a regular TI will look pretty square. So here's something you can do. Since we can't see the top of the local maximum here, let's hit this button called trace, right? And what the trace button does is it kind of gives you a blinker. Now, if we see on the lower left-hand corner of the screen, it says x equals -5, y equals -96, right? Right now, our cursor is located at that ordered pair. And that's the reason why we can't see the cursor. Because again, remember our viewing window is only from -10 to +10 on x and y. So if I hit the left or right arrow, we're going to see these ordered pairs change. And I want to try to I'm going to try to get this thing inside our window so we can actually see where it's located. And maybe there. This thing is going pretty crazy. So either way, what we're looking for here is just, what we're looking for here is just maybe some ordered pairs where we can see what's called a turning point, right? We see at x equals -5, the y values, as we move left, they're going lower. So if we raise them up a bit, we see it go from -68, the y values, -42, -20, they're going up, right? It goes up, y equals -0.1, x equals -0.4. I don't know why we don't see it. And we see the y values, again, still moving up. And then we see the y values kind of going up and then back down. Notice how the y values are going back down. Oh, there's our cursor. Excuse me. So that means somewhere about the upper 70s, we're seeing this, we're seeing the y values turn around. So let's hit the window button. And the window button lets you change your viewing window. Now we want the y maximum to be higher than 10. We want to be able to see that turning point. So let's put it at something close to the upper 70s, leave a little bit of space, maybe 95 is a good one. And then we'll hit the graph button and take a look at that. Now we can see the top of this graph. We don't want to get it, exactly. Oh, there's our cursor moving around as we hit the right and left arrow. Now we want to do the same thing for the local minimum. Again, as you move left and right, notice the values of y that are in blue, -62.1213, right? -73. We see them going lower, -73.7, -75.1, -75, and then -73 once again, -70. Now it's moving up. So somewhere along the lower -70, -80 range. Let's make our window, and let's move our y minimum now to like -95. All right, so let's hit the negative button, 95, and then we'll hit the graph. So now this graph looks nice and beautiful. As far as the x values go, what you're looking for is all three intersections with the x-axis. If you see all three, then you do not need to manipulate the x values of negative and positive. But if you don't see all three, take a look. We'll take a look at where these y values shift from negative to positive. Right here, y is equal to -11. And then y goes up to +6. that indicates that this graph crossed the x-axis somewhere. And that's what we're looking for with the roots. So using our tracer is pretty nice in that it will kind of give us a general idea, but the tracer usually does not tell you what the local maximum is going to be, right? It doesn't exactly, it can get close, but it can't do it exact. So in order to find that value exactly, we're going to hit the second button and then the trace button, which is the calculation feature. Oops, sorry, I pressed it too many times there. And we see a list of menus. Value 0, 3 is minimum, 4 is maximum. So let's take a look at the maximum right now. You can move down and hit enter. And you see up top it says left bound. Your TI-84, TI-83 is going to ask the same thing. Now what you're doing is telling the calculator where to look, because you can't tell it to look at the entire function. You only can tell it to look at a specific window. So let's find our cursor. Do you see this cursor, this blinker moving around? All right, so we want to make a window, a viewing window that captures this local maximum. So left bound means where is this calculator going to stop looking on the left-hand side? And where is this calculator now going to stop looking on the right-hand side, the right bound? And then it's going to ask for a guess. At least it should. I guess it didn't. Second calc, maximum, left bound, hit enter, right bound, hit enter. And I guess this one doesn't because it's a clone, but a TI-84 will ask for a guess. You can hit enter, and then it will tell you, see where it says maximum is negative 2.516 and then positive 79.004. So that's what you would put in here. You would put in an ordered pair of negative 2.516 and then 79.004. It says to round your answer to the nearest thousandth, so 3 decimal points is necessary. Right? If you are off, it's going to say you're close or something like that. So that's how you find a local maximum. A local minimum is going to be very, very similar, but again, for the local minimum, we are looking for the bottom of the valley over here. But the only slight difference is you're going to choose in the calculation menu, number 3, minimum instead of maximum. It's still going to ask you for a left and right boundary, so you can hit enter. And make sure again that your boundaries includes that minimum and only that minimum. And once you hit enter, again on a TI-84, it's going to ask for a guess. Hit enter again, it'll show you, those 2 arrows. And we see our minimum is at an ordered pair of 2.849 and negative 75.374. So 2.849 and then negative 75. What was that? 374. There it is. All right. So now let's move on to the roots. Remember, the roots are the location where this graph crosses the x-axis. So we see 3 of them here, right? Let's move our cursor all the way over to the left and take a look at that first root. Now again, I'm using a little fancier application. Your TI-84, 83, again, the trace blinker probably won't get close enough to be exact, and you can't trust it even if it looks it anyway. So let's hit second and use the calculation feature, and we want to look for choice number 2 where it says 0. Let's hit enter. And again, left bound and right bound. Again, we're telling the calculator where to look. There's 3 roots here. It has to get calculated one at a time. So hit enter, make sure that this is the left, and then move your cursor to the right, hit enter, make sure that your first root is within this viewing window. And you see it says 0 is x equals negative 4.5. So a root is an ordered pair. That's going to be negative 4.5 comma 0. And since there are 3 roots, that means we're going to put in 3 separate ordered pairs. Let's take a look at the next one. Right, we can see right over here is where the next root is located. Hit second and trace, or rather calculate, down to 0. Left bound, right bound, include the second root within this left bound and right bound again. And then we can see it says 0 is x equals 0.209. So that's going to be 0.209 comma 0 for the second root. And then the third root is located all the way in the right over here. So hit second, hit calculation, move down to choice number 2, hit enter for the left boundary, and then move your cursor, cross that root with the tracer, with the cursor, cross that root so that you can hit enter on the right boundary, 4.791, comma 0 is that third root. Right, so that's how you find a local maximum, local minimum, and the roots of a function using your calculator. Now, typing in different kinds of functions is tricky with a TI-84 or a TI-83. All right, let's look at part E, this rational function, x minus 3 over x minus 6. When you are typing into a graphing calculator, you have to make sure, with a rational function, you have to make sure that you are using parentheses, x minus 3 divided by x minus 6. Especially with these more complicated rational functions, you have to make sure that you have parentheses surrounding the entire numerator and then parentheses surrounding the entire denominator. Any other parentheses that are in there, maybe if this is in factored form or something like that, are going to be there in addition. So make sure that you are doing that, right? So if I hit graph, right, this thing looks real funky because this viewing window, remember, goes from negative 95 to positive 95 on the y-axis. Let's hit the zoom button. And if we go down to number 6, Z standard, this snaps the viewing window back into the standard negative 10 to positive 10 range. And this is our rational function, right? Our rational function looks like it has some things happening. We'll study that. But I just wanted to highlight this as a way to input rational functions when you are trying to do this homework exercise. And what this question is asking is this a function, right? Does this pass the vertical line test? And that's something that you should be able to answer visually. In order to input something such as y squared equals 9, you're going to have to solve for y. With y squared equals 9, take the square root of both sides, and that means y is equal to plus or minus 3. So take your calculator. Let's clear this off. y1 is equal to positive 3. y2 is equal to negative 3. And then we can graph this. Is this a function? Does this pass the vertical line test? And then you can answer it in web work here. All right, y squared equals x. You're going to do the same thing. Y squared equals x. Take the square root of both sides. That means y is equal to plus or minus radical x, which means we're going to have two separate functions here. One of them is going to be the square root. So second x squared is that square root button. Square root of x. And then negative square root of x. Be careful when you're using radicals. If you have a TI-83, the graphics are not as nice. So sometimes it uses parentheses, right? If that's the case, then you're going to have to get used to using parentheses to take the place of a radicand, right? To indicate what is the radicand. So be careful of that. Again, the graphics on this are pretty nice and much better than normal. So here's our graph: y equals radical x, y equals negative radical x. Is this a function? Does it pass the vertical line test? Right, and you can answer that right here. And you should be able to put this in and then see if it passes the vertical line test. This over here um, is a little bit tricky. So that's something we will cover later on. Thank you for watching, and I will speak to you in class.